let's just jump right into this explainer. Today, we're looking at how one of nature's absolute best ecosystems is actually inspiring the future of artificial intelligence. We hear a lot about AI agents lately, but as our tech scales up to tackle these massive enterprise problems, trying to get a single monolithic model to do absolutely everything, well, it's hitting a wall. So, to figure out what's next, computer scientists are actually looking at a system that has been perfecting complex, decentralized collaboration for literally millions of years. Yep, we're talking about the beehive.
Have you ever stopped to wonder how bees manage to build those perfect six-sided hexagons? It's pure math and physics. See, to make the wax for their honeycomb, bees have to consume about 8 ounces of honey just to produce a single ounce of wax. So it's incredibly expensive, energy-wise. They literally have to maximize storage space while using the absolute bare minimum amount of material. And by molding warm, soft cylinders of wax together, they naturally form these perfect hexagons. No wasted space, no wasted energy. It is a highly optimized, fully scalable system. And honestly, in the world of modern software architecture, that exact level of flawless optimization is what we're all chasing.
Now, right at the heart of this system is the queen bee. And let me tell you, the queen is an absolute machine. She lays over 2,500 eggs in a single day, driving this massive, perfectly orchestrated operation. To put that in perspective, that's actually more than her own body weight in eggs. But here's the real secret. The queen doesn't micromanage. She's not out there building wax, she's not guarding the door, and she is definitely not foraging for nectar. Instead, she provides the overarching orchestration, the lifeblood of the colony, while her specialized workers autonomously handle all the actual execution. And as we look at this comparison, you'll see this biological blueprint is exactly what computer scientists are borrowing to build multi-agent systems. Over on the biological hive side, you have decentralized control, where specialized actors operate on local views, and that leads to what we call emergent behavior. Basically, complex, intelligent outcomes coming from simple local interactions. Well, a multi-agent AI system operates on those exact same principles. Instead of one massive monolithic AI trying to do every single task, and probably doing them poorly, we use decentralized, specialized AI agents working together to create that same emergent intelligence. Which brings us directly to Google's Agent Development Kit, or ADK. So what is it? ADK is a Python framework designed to shift us completely away from that single do-it-all AI and move us toward a modular, highly scalable team. It basically lets developers build applications where multiple, highly specialized AI agents collaborate to solve complex problems. ADK gives you the organizational structure, the communication pathways, and super importantly, the guardrails to ensure these agents can reason, plan, and execute massive workflows without hallucinating or just totally breaking down. So, if we compare the two, those specialized worker bees map perfectly over to ADK's specialized subagents. Think about it. In ADK, instead of using one massive, overly complicated prompt trying to handle greetings, weather lookups, and database queries all at the exact same time, you spin up specific subagents. You might have a greeting agent, a data retrieval agent, and maybe a formatting agent. Because they're highly specialized, they are incredibly efficient and just far less prone to errors, just like a worker bee that's focused entirely on one specific job. But, to make any team work, you need coordination. Much like the queen bee overseeing the entire hive, ADK relies on a root agent to manage the workflow and delegate tasks to the right specialists. The root agent is basically your orchestrator. It receives the initial prompt from the user, analyzes exactly what needs to be done, and then hands off the specific tasks to the appropriate sub-agents to go execute. Now, a worker bee doesn't just do tasks randomly, right? Its life progresses through a very strict, specialized sequence. They start out as housekeepers cleaning the nursery, then they graduate to building the comb, then they act as guards, and finally they become foragers out in the real world. It's this beautifully, perfectly sequenced assembly line of tasks. Similarly, ADK's sequential workflow agent acts exactly like that assembly line. It passes data flawlessly from one specialized subagent to the next in a pipeline. Imagine a complex business workflow where you need to process a report. The root agent passes the task to the fetch agent to go grab the data, hands that output to the clean agent, passes that to the analyze agent, and finally down to the summarize agent. It's a beautifully orchestrated sequence that perfectly mirrors the biological life cycle of a worker bee. To manage these digital swarms, ADK neatly groups its orchestrators into 3 distinct workflow managers. We just talked about the sequential agent, that assembly line model. But sometimes, tasks just don't need to wait in line. For that, we have the Parallel Workflow Manager. This runs a subagents concurrently. It's honestly like a whole swarm of foragers hitting different flowers at the exact same time. And finally, there's the Loop Workflow Manager, which repeatedly executes subagents until a specific condition is met. That one is absolutely perfect for tasks like pulling an API for a status update.
Now, what's really interesting here is automatic delegation. This is where the magic happens. It allows the root agent to instantly pass a specific job, whether that's checking the weather or just saying a quick greeting, to the exact right subagent based purely on its description. In ADK, you give each subagent a concise semantic description of its skills. The root agent simply reads the user's intent, reviews the capabilities of its whole team, and dynamically routes the request. It's completely autonomous orchestration based entirely on specialized skill sets. And just as a forager uses its fuzzy pollen magnet hairs and its long tongue as biological tools to gather nectar, an ADK agent uses Python functions as its tools to pull in external data. In the context of ADK, a tool is a concrete capability. It could literally be an API called Google Maps, an SQL database query, or even just a simple calculator function. By equipping our agents with these tools, we empower them to interact with the outside world, just like a bee dynamically interfacing with a flower.
Okay, but how do they actually share what they find? Well, when a forager brings nectar back to the hive, she passes it from bee to bee to add vital enzymes, before finally storing it in a honeycomb cell for the whole colony to use. To coordinate all of this activity digitally, ADK agents use what's called a shared session state, which acts exactly like that physical honeycomb. It is a persistent memory layer where agents can basically store and share context, writing their findings, like user preferences or structured data points, so that the whole team can remember past interactions and use that context later. Grounding this metaphor in real enterprise tech, we can see how multi-agent collaboration actually uses defined architectural patterns to tackle massive workflows. Frameworks recognize specific structures, like the supervisor model, which is heavily hierarchical, much like our root agent and subagents, or the swarm pattern, which is entirely decentralized and peer-to-peer. These architectures allow businesses to scale their operations efficiently, carefully balancing the need for rigid control in high-risk workflows against the need for really dynamic flexibility. Looking at this design taxonomy reveals the serious architecture under the hood here. Specialized agents are equipped not just with varied AI models like Gemini, Claude, or Llama, but with dedicated memory banks, interaction protocols, and vitally, safety guardrails. In ADK, these guardrails are enforced via callbacks. Think of callbacks as critical checkpoints that happen right before a model runs or tool is used, mathematically ensuring the agent isn't doing anything outside of strict enterprise policy. And because we absolutely need to ensure these complex digital hives are operating safely, ADK provides robust testing tools. I mean, you wouldn't want a multi-agent swarm acting unpredictably in a live production environment, right? So you can run interactive web UI tests during active development to see exactly how the agents are chatting. Then you can save those interactions into command line evaluation datasets and ultimately run automated testing right inside your CI/CD deployment pipelines. This guarantees your multi-agent system is completely stable before it ever goes live. To wrap up our hive analogy, let's think about the ultimate result of all this work. When bees gather nectar, their fuzzy bodies accidentally spread pollen, creating a collaborative byproduct that literally feeds the world. I mean, we have bees to thank for about 1 out of every 3 bites of food we eat. Their primary goal is really just making honey for the winter, but their emergent, accidental side hustle, global pollination, sustains our entire global ecosystem. Which leaves us with a really fascinating question to close out this explainer. As we scale these biomimetic multi-agent architectures using powerful frameworks like ADK, what unpredictable and world-changing problem-solving will emerge from their collaboration? We are programming these agents to process enterprise workflows, fetch data, and manage systems. But as these digital hives communicate, share state, and autonomously optimize, what is going to be their equivalent of pollinating the world? It's a thrilling frontier for sure. Thank you so much for joining me on this deep dive, and keep learning.